today we are just working on multiplying polynomials that have a little different things in them. All of these have a little something different. It doesn't make them harder. It just makes them unique. So we talk about them because they're special cases. So first in the box up here, binomials that have the same variables and numbers in the same order. But here's the key. Different middle signs. Okay? They are unique ones. I don't really even know the term for this. I don't use the term for this.
You made the blank.
I know, I did, but I don't remember what I made that blank to be. Okay, so it doesn't matter. All right, so in that case, that's something like number 3. Okay? Same variables and numbers in the same order. They both have an x and a 7. The only difference is what? One is a plus, one is a minus. Okay? You don't do anything different. You can do something different with these if you would like to. If I was doing this just normally, most of us do the box. Okay, so I'll just show that. If you don't, just FOIL normally. Okay, so if I was doing this, I would put x plus 7 across one side, x minus 7 on the bottom, and I would multiply. X times x in the top box would give me what? X squared. The one to the right would be what? Plus 7x. The one in the bottom left would be minus 7x, and then negative 49. When I go to combine like terms, something special is going to happen here. And what is it? The x's are going to cancel out. This happens every single time. Okay?
Are you sure about that?
Yes. Every single time it's the same two terms, but one's positive, one's negative. The middle terms cancel out, and you end up with only the first and the last, with no x term in the middle. So number 5 would be very similar to that. That means that if you wanted to shortcut this, and you notice the pattern, so like let's say I wanted to shortcut this, and I did the box for number 5, I could just multiply the top left box and the bottom right box and use that as my answer, because every time those middle two are going to cancel out. Okay? So you may use that to shortcut. 5 is going to be the same as that. What else? 6. Take a minute. Try 5 and 6 on your own. All right, when you are done, check 5 and 6. 5 you should be getting 16x squared minus 9. That's the same thing. It's just reversed. Okay? So in number 6, because I wrote it this way because of how you multiplied, but if we were writing it as our correct way of writing it, you would put negative d squared first plus 9. That's fine. I would have accepted either or. Any issues with those two? Everything?
Wow, okay.
All right. Then the second box there, when an expression shows a binomial or a trinomial in a parentheses raised to a power. That's raised to an exponent. Okay? You must write out, okay, the parentheses part. The number of times the exponent indicates. So this is similar to when we did these with exponents a couple days ago. This is stuff like number 2 and number 4. So what does 2x plus 3 squared mean? 2x plus 3 times 2x plus 3. So this is not anything that you're going to do different. You're still going to box or FOIL or whatever you've been doing. What I see and what we see all the time is that people will just square the 2x and square the 3 and say that's our answer. That is never going to be your answer, and it will always be wrong.
Is this like the lessons for them?
This is kind of like that other lesson. Yep, you write it out the number of times you see it. So then 4, I would write out a plus 2 twice. And then box or FOIL. So take a minute, try 2 and 4. Let's check our final answer on 1. It's going to be 8x squared. Then what? Minus 2xy. Because that's mixed variables, we put it in the middle so because of the alphabetical stuff. And then minus 15y squared will go last. It typically does go in the middle because it's the mixed one between the x and y, so it's like we're blending over from x to y, finishing there. It wouldn't be wrong, no, but this is how you're going to see it in other things. Okay. Questions on that? All right. There's a couple other ones I want to try. How are we feeling about the 2s and 3s, like 7 and 8? Let's skip one of them. Let's not do 8 together. Okay, so take a minute and try 7 on your paper. However you do that. If you need to do a box for all of it, you can. If you need to just do the full distribution, you can do that. However you do that. Check your answer on 7 before we do 9 together.
What?
3 times 2.
Oh, no. I have a mouse.
Check that.
I put in C instead of a 2.
There you go. All right. Let's talk about 9 together. Why is 9 another one I'd want to talk about together? Because there's just like a distributing thing to do. There's 2 parentheses plus an extra. All right, so here is the thing. Here is the thing in number 9. We need to, at the beginning of 9 here, we need to ignore this. Okay? We're going to save that till the end. Okay? What do I do with these 2? We know how to do these 2. You multiply them together, use your box, you distribute, whatever you do, but ignore the W. Okay? So let's all do that however we do that. Ignore it. You do not distribute that first because, I mean, it's possible to, but most of you would do it wrong every time, so I tell you to wait. Okay. Yep, that's exactly what we're doing. So, on this then, we're going to multiply this out, get 6W squared plus 3W minus 4W minus 2. Hang on. So we're going to combine like terms now. 6W squared, when I combine my like terms, how many W's do I have in the middle? Minus 1W minus 2. Now, we distribute my W. Okay? What about 3W? Where is that? We combined that with this and got negative 1W in the middle. Okay. Once I distribute my W, that's a W to the first, what's that going to give me? 6W to the third minus what? W squared minus what? 2W. So anytime you have something like that, you do that last. Okay? It is not wrong to do it first, but here's what most of us would do. How many of you would want to distribute that W to everything? Most people would distribute it to the 2, to the 1, to the 3, to the 2. Okay? You would just do it to the first and then do the box, so that is also okay. But a lot of people don't do it, so it's good to wait till the end. Okay?
Would you only distribute to the first since it's only to the left?
Yes.
If it's in the middle, then you're good, right?
Yeah. All right. On the back, we have 2 problems more to do together, and we will be done. Okay, number 10 is incorrect. Number 10 is incorrect. S minus 3 to the second power does not equal S squared minus 9. What did they do wrong? They distributed the squared to both terms. What do we do instead? S minus 3 squared means what? S minus 3 times S minus 3. So what do I actually have to do with that? The box or distribute fully. Okay? Take a minute and do that. On 11. Okay? We're going to do several different things like this with 11. All right. Okay, we need to be able to solve for the width there. Okay? The garden is measured 12 meters by 16 meters. Okay? So you have that here. Okay? When we have a rectangle inside a rectangle, okay, it tells us together the walkway and the garden have an area of 396 square meters. Okay? So first thing that we can easily find the area of here is what? The garden itself. 16 times 12. What's that going to give me? 192. That's the area of the garden? What'd you say?
Yeah,
182? Okay. Okay, now we need to find also the area of the whole thing. Okay? So here's where it gets a little bit funny. If this is 16, this is x, and this is x, what is, or how could I represent this whole length? 16, because that's that middle part. Then what do we do with these sections on the side? Do we multiply them? Do we add them? What do we do with them? We add them. Okay, so we do 16 plus an x on one side plus an x on another side, which gives me plus what? 2x. Now we do the same thing down the side. This part's 12. This part's x. This part's x. So total length here is what? 12 plus 2x. Because you're going to do 12 plus an x and plus another x. Any issues with that? All right. How do I then, we just did this on our warm-up, find the area of the whole thing? What do I multiply together? I multiply 12 plus 2x times what? 16 plus 2x. Okay, so take a minute, and you can use this space down here to do the box or multiply that together. And then we're going to pause and check that together. So multiply that together. Right now, all we can do is make equations like this. Something we will do later, like in another chapter, is actually solve for what x is. Okay, we're going to learn how to solve one of these. But for right now, this is all we're going to do. Find the area expression. Issues with that? Okay. Going to ignore Tommy's issues and we're going to be done.